Hello and welcome to another video. So today we are going to solve this integral which was asked in JEE Advanced 2025 as you can see. So let's get started with this integral. So here if you just pay a little attention to the integral, so the limit is from half to 2, right? 1 by 2 to 2. So what we can do here is we can try the transformation. So if we put x equals 1 over d, then what do we get? Then we get dx equals, differentiating both sides, we get dx equals to 1 minus t square dt. So we can do these replacements. Also the limits. So half will change to 2, right? Because we have taken the reciprocal transformation here, and the 2 will change to half. So the limits will be from 2 to half. So alpha will look like, after doing all these transformations, we have 2 to half, lower limit and upper limit will interchange. Tan inverse of 1 over t, because instead of x you have to write 1 over t, and then in the denominator we have 2 over t square minus 3 over t plus 2, right? Then you have minus 1 by t square dt in place of dx. So now simplifying this, what we get is, we know that after removing this negative sign I can interchange the limits, right? Because what do we have? So we have a to b integral f of x dx can be written as integral from minus b to a f of x dx. So if you interchange the limits, a negative sign will pop out. So if I take this negative sign to interchange the limits, so I write half to 2 tan inverse of 1 over t as it is, divided by, if I take LCM in the denominator, what I get is, I get 2t square minus 3t plus 2, and then you have a t square in the denominator that will cancel out this t square right here. Okay, so let me just write it down into 1 over t square dt. So this t square will cancel out as we already discussed. So now what is the integral? So alpha is from half to 2. Now instead of t, I can just replace x, okay? And also this term here, tan inverse of 1 over t, I can write this as cot inverse, right? So I can write this as cot inverse of t divided by 2t square minus 3t plus 2 times dt. So replace t by x, changing of variables only. So I can write this as from half to 2 cot inverse x divided by 2x square minus 3x plus 2 times dx. This integral where we started, this is alpha, and now this integral is also alpha, right? So what if I add these two? Then tan inverse plus cot inverse will become pi by 2 in the numerator. So just add first and second equation, add 1 and 2. What we get is 2 times alpha, right? So 2 times alpha, and in the numerator you will have pi over 2, okay? Tan inverse plus cot inverse is pi over 2, and then in the denominator you will get 2x square minus 3x plus 2 times dx. And what's the reason behind this? So we have used that tan inverse theta plus cot inverse theta equals pi over 2, right? So we have used this fact. But now pi by 2 is just a constant, so pi by 2 will just come out, and then integral from half to 2, I can take 2 common from the denominator also, just to put it in the standard form. So you will get x square minus 3 by 2x plus 1, right? So this 2 will also come out. This is just a constant. So 2 alpha equals to pi over 4 integral from half to 2 dx, and then doing the square completion technique in the denominator for these term. So what we do is, so minus 3 by 2x. So if I have to make it a perfect square, I have to add and subtract 3 by 4 whole square, right? So if you just add a 3 by 4 whole square and subtract a 3 by 4 whole square, so this will become a perfect root or perfect square, right? So this is a perfect square of x minus 3 by 4 whole square, all right? So pi by 4 as it is, from half to 2 lower limits and upper limits. So it is nothing but dx over x minus 3 over 4 whole square. And then simplifying these two terms, so this is nothing but 1 minus 9 over 16, which is 7 over 16. So 7 over 16 you can also rewrite as root 7 by 4 whole square, right? So 2 alpha equals to pi over 4 integral from half to 2 dx divided by x minus 3 by 4 whole square plus root 7 by 4 whole square. All right. Now, this is the standard form, integral of tan inverse, right? Because we know that integral 1 over x square plus a square is nothing but tan inverse a, 1 by a times tan inverse a. All right. Tan inverse x by a. So this is nothing but 1 by a tan inverse x by a. So if I use this fact here, so what do we have for a here? A is just root 7 by 4. And instead of x, we have x minus 3 by 4, right? So using these facts, so instead of x minus 3 by 4, I have x in the formula. And root 7 by 4 will come in place of a, right? So use this. So we can actually solve this integral as pi over 4, then 1 over a. So 1 over a will be 4 over root 7. Then tan inverse of, instead of x, I have x minus 3 by 4. And then divided by a. So a is nothing but root 7 upon 4. And then you have to put the lower and upper limit from half to 2. All right. So let's just simplify this. So now we have 2 alpha equals to, so this 4 will cancel out here. So it will be pi over root 7 tan inverse of 4x minus 3 divided by root 7. And the limits are from half to 2. So let's just put 2 first, and then we'll put half. All right. So that will give me pi over root 7 tan inverse of 5 over root 7 minus, then we have tan inverse of, so if I put half, you get 2 minus 3 is minus 1, so minus 1 upon root 7. All right. So now tan inverse of minus theta is nothing but minus of tan inverse theta, so this minus will pop out. Okay. So this will become 2 alpha equals to pi over root 7 tan inverse of 5 by root 7 plus tan inverse of 1 over root 7. Now what is tan inverse A plus tan inverse B? So it is tan inverse A plus tan inverse B is tan inverse of A plus B over 1 minus AB, right? So now what do we have in place of A and B? So here A is 5 by root 7. And what is B here? B is 1 over root 7, right? So let's just plug in the values of A and B in the formula. So what we get is 2 times alpha into root 7 over pi. So this root 7 over pi I have shifted to the left side. And in the right side, you have tan inverse of A plus B. So this will be 6 by root 7 over 1 minus AB. So that will be 5 over 7, A into B. So simplifying this, what we get is tan inverse of 6 by root 7 divided by 7 minus 1, 5. 2 by 7. And the further simplification will give us 2 alpha times root 7 over pi tan inverse of, so this 2 will cancel out 3 here, and this root 7 will cancel out 7 here, and you'll get root 7. So this will be actually 3 times root 7, right? Okay. So now, if this value is tan inverse of 3 root 7, so tan of 2 alpha root 7 over pi is nothing but 3 root 7, right? And if I multiply root 7 both sides, so root 7 times tan 2 alpha root 7 over pi equals to 3 root 7 into root 7, right? And that will just give me 21. And this was the required value. So this was the required value and it comes out to be 21. So the final answer for this question was 21. And I hope you like the solution. So keep following for more such videos and we'll try to provide more and more solutions and more mathematics to you. So we'll see you in the another video. Till then, keep practicing and good luck.